Hello, everyone. So today we're going to continue to chapter 3, normal distribution. Normal distribution is the most important distribution in statistics. So anytime you talk about statistics, you can't get away from normal distribution, right? So this is very important. This is still on the second cluster of the class, probability and distribution. We have one more theory class to go. Then we're gonna go to inferences, right? That will be the last cluster. Okay. So again, go through the symbols very quick. So make sure you're familiar with all the symbols. At this point, I would expect you guys know all the symbols right now, everything before p-value and alpha. Okay. So sample size, little n, population size, big N, population standard deviation, sigma, right? Sample standard deviation, S, population mean, mu, sample mean, X bar, right? It could have be X bar or Y bar or A bar, B bar. Any letter with a bar on top represents sample mean. It depends on what you use to represent a variable, right? Okay. Standard normal variable. So we're talking about normal distribution now. So this is Z, right? And correlation between two numerical variables, correlation small r, regression slope and the regression intercept, B1 and B0. And p-value is probability of observing a sample as extreme or more extreme than the sample you collected. It's a probability, right? And alpha is type 1 error rate. They're both used in hypothesis test. We're gonna get there pretty quickly. Learning objectives. So understand the normal distribution is described with the density curve because normal distribution is continuous. All continuous distributions are described using density curve. We talk about density curve in chapter 10, right? We use uniform distribution with a density curve, a flat line on top of x-axis, right? Okay. But the sample space of normal distribution is from negative infinity to positive infinity. Okay. And then normal distribution has two parameters, mu and sigma. So I would expect you guys to understand how mu and sigma will affect the distribution. So basically, how would the density curve change when you modify mu and sigma? And then the key thing about learning any distribution is about finding probability, right? So how do I find probability from normal distribution? There's one quick and easy way to find probability that's using empirical rule. It's called the 68, 95, 99.7% rule. Okay, but the rule doesn't work very well. It's basically give you a rough picture, and it only works for a special event. The boundary has to be right on, the point. Otherwise, the rule doesn't work. So how do I find normal distribution systematically, for any scenario? Then we need to use a table. So that's what the Z table is, okay? The Z table shows a distribution. That's a Z distribution, standard normal distribution. And then once you know how to find, how to use Z table, then for any other normal distributions, we have a conversion. We're able to convert other normal distributions into a standard normal distribution. That way, you can solve any normal problems using that one table. And able to use normal distribution to solve practical problem. We are applied statistics. We always want to solve practical problems. That's our end goal, right? Right, so let's start with normal distribution. Normal distribution is a distribution, continuous distribution. So we use a density curve to describe the distribution. And if you recall, the density curve has two axes. This is X is the variable of interest, and Y is probability related, right? And the normal distribution is going to be symmetric bell-shaped density curve. Okay, so since it's symmetric, then the median and the mean will be right in the center, right? So this point will be median, also it will be mean, right? Because it's symmetric distribution. And then also, if you realize that the center point is also called a mode, right? So mode, mean, and median, they overlap for normal distribution, you know, like this. This is normal distribution. Mean, median, the mode, they overlap in the center. So whatever this mark is on x-axis, this point, whatever the mark is, that's mean, median, and mode. But some distribution has, you know, a skewed shape of normal distribution. So it looks like normal, except that it's not symmetric. So in this case, mean and median and mode, their location will change. Okay, so how would that change? Mode is easy to locate. Once you have a density curve, the highest point is most likely, right? That's what a mode is. Mode is most frequent, most likely, right? So this mark on x-axis is mode right here. The mean and median will change by the skewness. So how they be affected. So this is related to the resistance measure we learned in chapter 2. So between mean and median, which one is resistant? Which one is not affected by the outlier? Median is resistant, right? So when you have a skewness, that just like you have an outlier on the left end. So the outlier will try to drag mean and median both away from where they were. But since median is resistant, it's going to resist to the pole, and mean is not resistant, it will be affected further, right? So mean will be more on the skewed side, median will be less on the skewed side, right? So you have mean, median, mode, the relationship for the left skew distribution. For the right skew distribution, same idea. Mode is easy to identify, highest point, most frequent value. And mean is more on the skewed side, median is somewhere in the middle, right? So that's the relationship between mean, median, mode for skewed normal distribution, right? So normal distribution has two parameters, mu and sigma. And of course, we know the symbols now, right? Mu is population mean, sigma is population standard deviation. So mu is population mean. So basically, whatever this point is on the center, this is mu right here, right? And sigma will be a measure of spread, right? Standard deviation is a measure of spread. So the larger the spread, the larger the standard deviation, right? So then how does mu and the sigma affect the look of the normal density curve? We're going to look at some examples, right? So normal distribution is two parameters, mu and the sigma. Normal distribution is continuous. The sample space is all real numbers between negative infinity to positive infinity. So it basically goes, you know, on and on both sides of the axis. So we have two sets of graph here. For the first set, we have three normal density curves. Okay, population mean will change from -5 to 0 to 5. And if you can look carefully, you know, if you draw a line on the center, it will point directly to the mark -5 here, and this point to 0 on axis, and this will point to +5 on x-axis, right? So the standard deviation always set to equal to 1 on the first three normal density curves. So you can see that when sigma equal to the same, then the spread of the three density curve are exactly the same. So sigma is determining the spread, right? And what is mu determining? When mu increases from -5 to 0 to 5, what happened? The height is staying the same, right? The height has nothing to do with population mean. That's probability. So the center change, right? Mu is the center of the density curve. When you get a higher value, the center will shift to the right, right? The right is bigger number, okay? So mu is determining the location of the center of the density curves, okay? And on the right-hand side, we also have 3 normal density curves. We have mu all equal to 0. So if you look at the center, all 3 density curves point to the 0 on x-axis. They have the same population mean. And the population standard deviation will change from 1 to 2 to 3. And you can see that when population standard deviation get bigger, the density curve get more flat, right? It more spread. So sigma is determining the spread of the normal density curve. Okay. So population mean of the normal distribution can be any real number. Any number between negative infinity and positive infinity can be population mean. But population standard deviation sigma has to be a positive number, right? When you calculate sample standard deviation, it's a square root of something. Sigma is the same calculation with S. It's just you need to have data from the population to calculate it. Okay, so sigma has to be a positive number. So now we know how mu and sigma affect the normal density curve look. Now, if I give you a 2 normal density curve shown as here, can you tell me which one has a larger mean, which one has a larger standard deviation? So it's kind of clear B has larger standard deviation because it's more spread, right? More spread means larger standard deviation. But who has a larger mean? A or B? So some people will get confused here. The center of A is right here. The center of B is right here, right? Which is centered to the right? B, right? B is centered more to the right. It has a larger standard deviation, larger mean. So if you recall, we look at this. When the mean increases, the center of the density curve will shift to the right, right? All right, the same idea. If you have this 2 normal density curve, which one has a larger standard deviation? Of course, A, right? Then which one has a larger mean? So B has larger mean, right? Because B is more shifted to the right, right? The center of the B is to the right of center A, so it has a larger mean. Right. So now let's talk about how do we find normal probabilities. So if you have a normal distribution, how do we find some, a normal event probability? How do we find area? When you have a density curve, finding probabilities, finding areas, right? Recall in chapter 10 when we talk about the square, the rectangle shape distribution, probability of any event is just the corresponding area. Except that in the rectangle shape, we can calculate the area using the geometry formula. But when you have a normal density curve, there's no geometry formula to work here. So we need to use some other tools. Okay. So first thing is 68, 95, and 99.7% rule. The rule is very simple. So imagine if you have a normal distribution. Population mean is mu. Population standard deviation is sigma. Right? So the total probability under the density curve, that will be 1, right? Probability of any sample space equal to 1, right? So everything under the density curve is always 1 for any distribution, 100%. Okay. So then we have a rule called 68, 95, and 99.7 rule. What does the rule say? It says if you have the center of the normal distribution, and if you measure 1 standard deviation from the center to both sides of the normal distribution, then you're going to have an event to enclose the middle probability, right? So then this area in the middle, this probability will be 68%. Okay. And then likewise, if we have a normal distribution, but now if you measure 2 standard deviation from the center on both sides, then the middle probability will be 95%. Okay, and everyone can guess what will happen to 99.7, right? That will be if you measure 3 standard deviation on both sides of the normal distribution from the center. So the middle probability will be 99.7%. So the rule is very simple, right? We have 3 numbers to remember: 68, 95, and 99.7. And of course, everyone remember 1, right? 100%. That's for the total area under the density curve. So that's what the rule is, okay? And now we can use the rule to try to find some probabilities. So for example, the scores of a dose IQ test are approximately normal with mean of 100 and standard deviation of 15. First question, the organization of Mensa require IQ score to be 130 or higher for membership. So what percent of adults would qualify for membership? All right. So let's try to figure this out. So we know a variable x has a normal distribution with mean of 100 and standard deviation of 15, right? So the first number is mu, second number is sigma, right? Now, if we draw a density curve of this normal distribution, we have mu of 100, right? So then we're asking what percent of adults will qualify for membership. So qualify for membership, what does it mean? From the criteria, we need to look for a probability. Then what's the event? The IQ score is X, and they need to be higher than 130, right? Higher than or equal to. So then if we find the corresponding area for this event, that area will be this probability, right? So let's go ahead and find the area. So that's 100. 130 will be somewhere to the right. And then the event is greater than 130. So you're looking for area to the right, right? So how do I find this area? You know, if this is a rectangular shape area, it's easy, right? Like in chapter 10, but this is not. So we need to use something else. And here we're going to use the empirical rule, the 68, 95, and 99.7 rule. So we realize 68 is for 1 standard deviation, 95 is for 2 standard deviation, and 99.7 is for 3 standard deviation, right? So then for finding an area of the tail, first we need to determine the distance from the center to the boundary of the event, okay? So the distance is from 100 to 130, the distance is 30, right? And we know 1 sigma is 15. 30 is how many sigma? It will be 2 sigma, right? So this is 2 standard deviation away. And for 2 standard deviation, we're going to use 95% rule, right? To make a full 95%, we need to extend 2 standard deviation to the left of the normal distribution, right? So the middle probability in between is 95%. So we're looking for this one tail. The total amount of distribution is, total amount of probability for the whole distribution is 100% or 1. The middle is 95% or 0.95. So both tails on the left and on the right together will be 5%, right? So it will be 100% minus 95%, right? And then that's 2 tails. If we just want to have 1 tail, we know that from the symmetry, this tail and this tail are exactly the same, right? So if that's the case, we divide it by 2. So it will be 2.5%. Okay, so that's the answer for the first question. Only 2.5% of the student, the adults will qualify for the membership if that's what they're setting as. Okay. And next question, what range of score of a 95% of adults fall in? So, you know, center is 100, 95% will be 2 standard deviation in both way, right? And 2 standard deviation will be 2 times 15, which is 30, right? So 30 to the left will be a 70 mark, 30 to the right will be 130 mark. So it will be between 70 and 130, right? And next, what percent of adults have IQ score lower than 115? Right, so it's very similar to what we did here. So I'm gonna go ahead and do this real quick. So we're gonna have a normal distribution. It's very helpful to draw the density curve out. It doesn't have to be perfect when you draw the curve, okay? I'm drawing pretty badly using the mouse here. So we have a normal distribution, mean is 100, right? So now we'll need to find the event. The event is probability of X is less than 115. So pay attention to the sign. Now it's smaller than, right? Smaller than means it's to the left, right? So we need to find the 115 mark, roughly. It's going to be here. So we need to find the probability from here all the way, right, to the left. So then once you find a shaded area, we're going to need to determine which route to use. And to determine which route to use, we're going to find a distance from the center to the boundary of the event. So from 100 to 115, the distance is 15, right? And that's how many standard deviation away? How many sigma? We know sigma is 15, right? So this is exactly 1 sigma away. And that distance will tell us what number to use. 1 standard deviation, we're going to use 68% rule, right? Okay. So then how do I work on this continually? So if we separate the total area by 2 pieces, this is piece 1, this is piece 2. Then we know the probability we're looking for will be the sum of the 2 area, right? Will be area 1 and area 2 together, right? Now what's probability of area 1? So normal distribution is symmetric distribution. The total distribution is 100%. And the center line is the symmetry point. So everything to the left of the center line will be 50%, right? Basically, it's a 100%, take a half of 100%, right? And now what's piece 2? So imagine this is a 68 rule, then we need to make a full 68%. So if you make a full 68%, you're gonna extend one standard deviation to the left. Then the middle will be 68%, right? But this side and this side, they are symmetry, so they should be the same, right? Then if you just look at one side as part 2 alone, it should be what? It should be half of 68%, right? So then you just calculate. You have 50% and 34%, so you got 84%. So that's probability of X smaller than 115 using the empirical rule. And then what percent of those have IQ score lower than 70, right? Lower than 70, we know 70 mark is right here, right? So basically it's very similar to the first one. Lower than 70, you're looking at the other tail right here, right? And by the symmetry, it's the same as this area, right? So it's 2.5% as well. Either left tail or right tail, but they're the same probability. They have the same area. So that's empirical rule. And here's a practice to find the probabilities. If there's a similar settings, we're gonna go through this real quick, and hopefully that will help you to make sense of this. You just have different parameters, but it's still a normal distribution using, empirical rules. So if I say the weight of adults are normally distributed with mean of 170 and standard deviation equal to 30. So if you write it out, it will be variable X as the weight as normal distribution, and then with mean of 170 and standard deviation is 30. Okay. So the first question, what percent of adults have weight higher than 200 pounds? So looking for probability of X is greater than 200. Right? So it's always helpful to draw a density curve for any time when you look for normal distribution. Okay, draw a density curve. Mean is 170. And then find the shaded area for the event you're looking for. Greater than 200, 200 is to the right. And greater than, that means to the right of the 200 line. So looking for right tail probability, right? Then we're gonna use 68, 95, and 99.7 rule. So then we need to know what rule are we supposed to use. There's 3 different rules here, right? So determine what rule we need to use. We're gonna measure the distance from the center to the boundary. It's always from the center to the boundary. So from 170 to 200, the distance is 30, right? But we're gonna use number of standard deviation to represent the distance. 30 is exactly 1 standard deviation. Right? So if it is 1 standard deviation, we know we need to use 68 rule. Right? So we can find this probability. So, the rest is very similar to the practice we've done before. If you want to make a full 68%, you need to extend 1 segment to the left. Then the middle probability will be 68% by the rule. Then you have 2 tails. This is bad drawing, but from the symmetry, this tail on the left and this tail on the right should be the same, right? It's because normal distribution symmetric. Then this probability will equal to 100% as a total, subtract the middle 68%, and then that would be the two tails add up, right, together. But if you want to just have one tail, you divide it by 2, right? And then the rest is math. So 32 divided by 2 is 16%. So that's part 1. Right, part 2. What percent of adults has weight higher than 260 pounds? So we're looking for probability of X greater than 260, right? It's exactly the same process as what we did here, right? So if you draw a density curve, mu is 170, and 260 is to the right here. And then you need to shade the area of interest. So which side are you looking for? So greater than sign is to the right of 260. So in order to find this area or probability, we need to determine what rule to use, right? So we're going to determine the distance from center to the boundary. From 170 to 260, the distance is 90, right? If one sigma is 30, how many sigma is 90? It will be 3 sigmas, right? So 3 sigma, we're going to use 99.7 rule, right? And the same deal. To make the full 99.7%, we need to extend 3 sigma to the left. Then the middle probability will be 99.7%. So then you have 2 tail left, the tail on the left and tail on the right. The middle is 99.7%, right? So, just like what we did earlier, this probability will be equal to 100% total minus 99.7% in the middle, and then divided by 2 because you only need one side of the tail, right? So there'll be 0.15%. Okay. So that's part 2. Part 3, what percent of adults has weight between 140 pounds and 230 pounds? So if you write the event out, this will be probability of X is between 140 and 230. So I need to understand how to write the event out, right? In between, right? So I have 2 boundaries. Then if you draw the density curve, I think I'm getting better at drawing here. So mu is 170. And now the event has 2 boundaries. 140 will be to the left of 170 somewhere. And 230 will be to the right somewhere. So we need to look for the probability in between, right? Again, we need to try to use the rule here. We need to know what rule to use. So then we need to determine the distance from the center to the boundary, always from the center to the boundary. So to the left boundary, the distance is 140 to 170, that's 30, right? 30 is exactly 1 standard deviation away. Then on the right boundary, the distance is from 170 to 230, that's 60 distance. 60 is exactly 2 standard deviation away. So you can see here, we have 2 different distances. That means we need to use 2 different rules. We need to use 2 rules for this one problem, right? Okay. So how do I find this area or probability, right? Probability is the same as area in density curve. So if you separate the total area or probability into 2 pieces, piece 1 and piece 2, we can see that this area will equal to 1 and 2 adding up together, right? So now, as long as we find 1 and 2 together, then we're able to solve the problem. Okay, so one standard deviation on the one side, this is one standard deviation for the distance. We need to use 68 rule, right? Imagine if you draw 68%, if you draw full 68%, you need to extend to the right one standard deviation, right? But it's symmetric on the, from the center line. So if both sides together is 68%, if you only look at piece one, that will be half of 68%, right? That's piece one. And piece two, the same deal, right? Piece two is for 95% rule. So if you want to make full 95%, you're going to extend 2 standard deviations to the left. So the total probability in the middle is 95%. If you cut in the middle, it cut at 95% into half, right? So piece two will be 95%, take a half. And then the rest is calculations, right? So 81.5%. So that's number 3. And number 4, you're looking for probability of student body weight is less than 140 pounds. Less than 140, we can draw density curve also. Oh, I'm sorry. This is supposed to be 170 for the center, not 140. So population mean is 170. And 140 is a boundary somewhere, right? It will be to the left of the center. And then which side of the area you're looking for? You need to look at the sign, right? Smaller than sign means to the left. Smaller than. Then to find this area, we need to check which rule to use, right? So we're going to determine the distance from the center to the boundary. From 140 to 170, the distance is 30, and 30 is exactly 1 standard deviation away. Right? So it's 1 standard deviation away, we're going to use 68 rule, right? To make the full 68 rule, we need to extend 1 standard deviation to the right. So the middle is 68%. Then you have 2 tails, one on the left, one on the right. They have exactly the same shape. They have the same area, right? So then if you continue, so this will be 100%. That's the total distribution. Subtract the 68% in the middle. And then this will be both tails on the left and on the right. If you just want to have one tail, we divide it by 2 because they're the same size, right? So it'll be 16%. Okay, so we can use the empirical rule to find some normal distribution probability very quickly. All right, so now let's look at the last one. The last one, we're looking for a probability of student adult, what percent of those has weight greater than 185 pounds. All right, so if you draw a density curve, just like what we did earlier, so mu is 170, and the sigma is 30, and they're looking for a boundary of 185. And they're looking for the probability to the right with a greater than sign. Right? So you try to use a rule, so you're going to determine the distance. The distance is 15 from 170 to 185, but how many standard deviation is that? That's a half of a standard deviation, right? By the way, don't have a half of a standard deviation rule. We only have 1 standard deviation, 2 standard deviation, and 3 standard deviation rule, right? So we're stuck here. We can't find this probability using the empirical rule. So the empirical rule can only work if the event they are looking for is bounded by exactly the 3 points that, for the 3 rule. Exactly 1 standard deviation, 2 standard deviation, 3 standard deviation away from both sides of the population mean. If the event is bounded by any other event, the rule doesn't work anymore, unfortunately, right? So the empirical rule is very useful, but it's not that useful. It only works on some certain problems, but it's not a general solution, right? But for normal distribution, if you want to study it, we want to find probability of any event we're interested in that distribution. So we need to find another approach. And that's where we introduce the Z distribution, right? So we're going to go to Z distribution now. So here is the second animal for attendance check. It's a rabbit. So we're going to define a spatial distribution. We know normal distribution has 2 parameters, mu and sigma, right? If we set mu equal to 0 and sigma equal to 1, that's a standard normal distribution. We call that a Z distribution. Okay. So a Z distribution has population mean equal to 0, population standard deviation equal to 1, and it's a normal distribution. And for any other normal distribution with various population mean and population standard deviations, we can use a standardization process to standardize those normal distributions into Z by the transformation of Z equal to X minus mu divided by sigma. So then if we're able to deal with Z distribution, by this transformation, we're able to deal with any normal distribution problem. So that's the idea. We just need to have one normal table to solve any normal distributions with various population mean and the population standard deviation values, right? So now this is our Z table, okay? So with this table, we're able to, find any normal event probability. So we're going to spend some time to learn about how do we look up this table? How do we use this table, right? So I hope you guys can read. I know that the font is very, very small on this table and it's hard to read, but I attached a file so you can download and print it out. That's maybe it's easier for you to look at. So this is a Z table. In a Z table, you have 2 types of numbers to read. One is Z-score. The other is probability. Okay, so you have 2 sides of the table. On the left-hand side and the right-hand side, they have exactly the same structure. On either side, the Z-score is going to be a number combining the first column and the top row together. So for example, if you want to read 1.18, you need to find 1.1 here and 0.08 here. So together, that's 1.18. Okay. Right. So then all the values inside the table, here and here, those 4 decimal places number, they are probability values. So you have 2 sets of numbers, a Z-score and probability. Okay. So then in the Z table, you basically have a 1-to-1 match of all the Z-scores and probability values. So for example, 1.00. So 1.00 will match with probability of 0.18. 0.8643. And 1 point, oh, I'm sorry, this is 1.10, right? 1.10 will match with 0.8643. And 1.11 will match with 0.8665, and so on, right? So you have many, many different pairs of the z-score and probability. So then what does it mean? You know, we know then there is a relationship between the z-score and the probability, right? So for example, let's find a pair, okay? So for 0.70, for a z-score of 0.70, what does it match with the probability? So the probability matched with z-score 0.7 will be 0.7580. Right? So there is a relationship between the z-score and the probability. Then what is that relationship? That relationship is given on the top density curve here. Okay, so the shaded area, that will be the probability value you read. So that shaded area is the probability. And then the z-score is going to be the boundary. Okay, so then if you think about our scenario, if you read a pair of 0.70 as a z-score and 0.7580 as probability, that will correspond to you have a z distribution center at 0, standard deviation equal to 1, right? This is a z distribution. So when z equal to 0.70, then the probability to the left of that z-score will equal to 0.7580. Okay, so understand that, right? So now we just need to get used to how we write it into the format, you know, of mathematics. So the shaded area is a probability of an event, right? Then what's the event? The event is going to be related to z, right? With a boundary of 0.7, right? So then when z is less than 0.70, that area probability will equal to 0.7580, right? So then in Z table, just basically provides you many, many relationships just like this, right? And that's it. That's how you read the Z table. Right? So now if I ask you to find probability of Z is less than 1.12, can you find what that probability is? You know, that's the same algorithm in here, right? So if you want to find probability of Z less than 1.12, it's consistent with the Z table layout. All you need to do is find the counterpart of Z score of 1.12, right? So if you look for Z score of 1.12, 1.12, so the corresponding Z score matched with that probability matched with that Z score is 0.8686, right? So this probability will be 0.8686, and that's it. So we can find probability of a Z distribution. But this is when you try to find the probability to the left of a Z score. But sometimes we are interested in finding probability of Z greater than a Z score, right? Or maybe you can just use 0.70 since we have the density curve drawn up there. So what if you want to find probability of Z greater than 0.70? So you're looking for the area to the right now, right? How do you find the probability to the right? And some already figured it out, I think, right? The total distribution has probability of 1. The total probability of any distribution has to equal 1. If to the left is this much, to the right has to be 1 minus that much, right? Because total add up 1, right? And here basically you can use a complement rule, what we learned in chapter 10. So probability of z greater than 0.70 will be probability of 1 minus probability of z smaller than or equal to 0.70, right? And equal sign doesn't really matter in continuous distribution because single line doesn't have any area, right? So then this will be 1 minus 0.7580. And you can calculate 0.2420, right? So this is how you find the probability on the right tail. Just use 1 minus to the left, right? And to the left, you can look up exact, as is from Z table. Right. So then for normal distribution, now we're able to find probability from any point to the right. We're able to find the probability from any point to the left, right? To the left, you just look up as is, right? What if we're trying to find the probability in the middle? A middle slice is not on the side. How do we find that, right? So let's work on practice on that. So probability of z between 0.70 and 1.12. So how do I find this probability? Okay, some students got struggled on this, but it's very easy to understand if you're drawing a density curve out. So this density curve, a z distribution, and the center is 0. And this point is 0.7. And this point is 1.12. So you're looking for probability of z between the two z-score. You're looking for the area in between, right? So now we're going to draw 2 more density curves. This is a z distribution. And here, it will be from 1.12 all the way to the left. So that's the area. And this is another density curve with a z distribution. And this will be from 0.70 all the way to the left. So for the 3 areas, what's the relationship? This area is from this point, 1.12, all the way to the left. And this area is from 0.7 all the way to the left. A little geometry, you can see the first area will equal to the difference of the other 2 areas, right? So this subtracting this will equal to this, right? And then that's exactly what we need. So basically, for the first for the probability of interest, we just need to set it to be equal to, I'm gonna get rid of this sign. So this area is this event, right? And this area is corresponding to what event? it will be to the left of 1.12, right? And this event is, if you write it out, what would it be? So it will be probability of z less than 0.7, right? And we know this area equal to this minus this, then that means this event probability will equal to this probability subtracting this, right? And that's it. Then for these two probabilities, we can look up. We already looked up from here. Z smaller than 1.12, the probability is 0.8686. Then subtract. Probability of Z less than 0.70 is 0.7580. And we just need to subtract one from the other, right? So if you do the calculation, that'll be 0.1106, right? So that's the probability of interest. Okay. So now we're able to find normal Z distribution probability for any scenarios, either on the left tail or on the right tail or a slice in the middle, right? With the left tail, we look up as is. With the right tail, we subtract from 1. With a slice in the middle, we look up both probabilities for each boundary and then do a simple subtraction. And that's because of the density curve we draw, right? This area, because of this area, subtract this area. And that's how we look up probability from Z table. All right. So make sure you're, understand how to use Z table. This is very, very important. We're going to use it a lot. If you have any questions, don't hesitate to contact me. And then we have practices. So we can find the probability of events, for probability of Z less than 1.54, Z greater than 1.54, or in between 1.54 and 2.53, right? So it will be helpful that you draw density curves, but if you already have a good understanding of this, then you don't have to draw it, but drawing the density curve will definitely help, right? So for example, if you want to find the top probability with a smaller than sign, if you're familiar with it, this is smaller than sign, it's consistent with the Z table. So we look up as is 1.54. So 1.5 and 4, right? So the matching probability is 0.9382. So this will be 0.9382. And then probability of Z greater than 1.54, that's simple, right? Just 1 minus probability of Z less than 1.54. So to the left and to the right of the same Z score, they add up to 1. That's the total distribution, right? So then this will be 1 minus 0.9382. That would be 0.0618. And the next one, probability of Z between 1.54 and 2.53. So we need to convert it, right? The probability of Z smaller than 2.53, subtract probability of Z smaller than 1.54. Right? So then we can look up for each. They're smaller than sign already. So 2.53, 2.5, 3 is here, 0.9943. And then 1.54, probability of Z less than 1.54, I just looked up, 0.9382. And then we calculate, right? And that's it. So 0.0 and 5, 6, 1, right? So this is how to look up Z table for probabilities. All right, so this is one way to look up a Z table. There's another way, and that's more confusing way, but we need to use it later on, so we have to learn that as well. So earlier we mentioned for a Z distribution, from the Z table, you have a one-to-one match between any Z score and any probability, right? So for example, for any Z, the area provided to the left of that Z will be probability, right? So what's the relationship between Z and P? We talked about it. So it's going to be probability of, this is Z as a variable, and to the left of a particular Z score will equal to a probability given, right? So whatever Z you're looking for will be going here. Whatever P for the match pair will goes here, right? So you have a relationship like this. Then the deal is, if you're able to find from Z, given Z to a given, to a probability, then aren't we supposed to be able to find a Z score with a given probability? So basically, if you know there's a one-to-one match between two values, then for given any value, you can find the other, right? Also think about the routes. If you're able to drive from home to school, then you should be able to find, way home from school, right? And back and forth, right? So this is the idea. So how do I find a Z-score with a given probability? So for example, if I'm saying, look for a Z-score, a Z of 0, a particular Z-score, so that probability of Z less than that Z-score will equal to 0.9382. Right? So how do I find that Z-score? So on the Z table, we're given probability. So we need to match a probability in the Z table. So 0.9382, you just keep looking. This is an increasing order, so it's not too bad. When the number is smaller, just keep looking, right? So 0.9382 is right here, right? Then the Z-score matching with this probability has to be 1.54, right? So then we can say that the Z-score we're looking for is 1.54. And that's it. Then another thing is, in the Z table, Z distribution is continuous distribution. There's infinite number of different Z scores. But if you have a table, there's no way a table can list infinite number of values, right? So when you try to look for something that's not on the Z table, you couldn't find the exact match. We need to be ready for approximation. So the idea is, for example, if you try to find probability of Z is less than 1.548, right? Of course, you can't find 1.548 on the z-score here. You only have 2 decimals. Then this will be approximately equal to probability of z less than 1.55, right? Then the problem solved. You approximate it a little bit, right? And then 1.55 is 0.9394. This is easy to understand for approximation like this, but sometimes, what if you try to find probability of z smaller than 6? And you look at the z table, hey, 6 is not even down here, right? It's outside of the boundary. The boundary is 3.49. You don't have anything above 3.49. Then what do? Approximate it. You know, what's the closest z-score compared to 6? The closest on the z table is 3.49, right? So you just use whatever that probability is to match it, to approximate it. Okay. So we can approximate z-score, then sometimes we need to approximate probability as well. So for example, if you are asked to find a z-score so that probability of z less than that z-score will equal to 0.10. I want to put them on the same line. So right. So then we need to find the probability of 0.10 on the z table. You know, 0.10 is going to be on the left-hand side of the table, right? So we're going to look probability of 0.10. So probability of 0.10, this is 0.0, not 0.09. It's closer to 0.10. And here is 0.10 something, right? So find the closest. And you can see that we have 0.1003 and 0.0985. They are the closest to 0.10, right? So as long as you use, you know, one neighbor, all the probability given will have 2 neighbors. As long as it's one neighbor to approximate it, then you'll be fine in this class, right? So here, basically, you can approximate it, say, hey, you know, I couldn't find probability of 0.10 here, but I can find a probability of 0.1003, and I think that's close enough to 0.10, right? So then from here, we can say Z0 is the corresponding value for 0.1003, which is negative 1.28, right? So that's the deal. So with a given probability, we can find a corresponding z-score for it, right? So this is with a smaller sign in the event. Sometimes I could ask you to find a z of 0 so that probability of z greater than z of 0 equal to 0.10. So now this changes the whole thing, right? So it will be helpful if you draw a density curve out to figure this out. So if you have a z distribution, center is 0, and we try to find a z of 0 here to make the probability to the right of z0 is 0.10. So this is what we're looking for. By the way, no, z-table is not designed this way. Z-table only give you probability to the left. So if the probability to the left, to the right of z0 is 0.10, what will be the probability to the left of Z0? Will be 1 minus 0.10, right? Because total probability for any distribution has to equal to 1. So then we just need to do a simple transformation here. So if probability of Z greater than Z of 0 equal to 0.10, then probability of Z smaller than Z of 0 will equal to 1 minus 0.10 will equal to 0.9, right? So it's the same Z of 0. When they cut the right tail to be 0.10, the same time it cut left tail to be 0.90. And then the question becomes what we did earlier, right? So you change the sign to be smaller in sign, then we can look up the Z table. So we're going to match on the Z table with 0.90 of probability. So 0.90 is going to be between 0.8997 and 0.9015, right? So it's very similar. We need to approximate here. So we couldn't find 0.90 exactly, but we're able to find 0.8997, right? And then the corresponding Z0, we can approximate it to be the corresponding Z-score, 1.28. Right, so this is how I look up Z table for, from Z-score to probability and as well as from probability back to Z-score. Right. So if we know how to find use Z table, then we're able to find, any normal distribution probability. So please practice some probability lookups. Make sure you understand how to use Z table to look up probabilities, and we'll go from there, right? So I can practice a few questions with you very quick. So for example, we're going to find a Z-score so that probability of Z less than that Z-score equal to 0.6628. I'm going to get rid of all these. So probability of Z less than Z of 0 equal to 0.6628. Then what is Z of 0? Right? If you are already familiar with the sign, you can figure out, hey, you have a smaller sign that's consistent with the Z table, so you don't need to do anything. If not, you can always draw a density curve. So make sure the area shaded always to the left. That way, it's consistent to the Z table. So you have a smaller sign, that means to the left, right? So it's consistent with our Z table, then you can always just look up as is, right? So 0.6628, we can just look up as is, 0.6628. All the probability smaller than 0.5 is on the left-hand side, greater than 0.5 is on the right-hand side. So 6628 is on the right. 6628, right here. And the corresponding Z-score is 0.42, right? 0.42. So Z-score is 0.42. And next question, we need to find a value of Z-score so that probability of Z greater than Z of 0 is 0.98. So we're going to bring this to here. All right. So the problem is here you have a greater than sign, right? Greater than sign is to the right. Drawing the density curve will help you to realize that. So we know we're not able to find that directly. We need to convert it. Probability of Z less than Z of 0 will be 1 minus 0.98. and that equal to 0.02. And now it's consistent with the Z table. So we look up in the Z table with probability of 0.02. 0.02 will be on the left-hand side of the table. So we look as close as you can, find 0.02. So we can see there is a 0.0202. That's very close, and 0.0197. You can use either one to approximate. So for example, if we approximate this equal to 0.0197, then the corresponding Z of 0 will equal to negative 2.06, right? So this will equal to negative 2.06. So pay attention to the signs. Right. So this is how to look up Z table. We're going to take a break here, and we're going to continue next lecture to finish normal distribution. Right. So send me any questions that you have.